All right, welcome everyone. Glad you were able to stick around even with our delay here. My name's Jake Sobolski. I'm a program manager on the Windows Developer Experience team. And I've been at Microsoft for about 4 years now. And for most of that time, I've been working on various aspects of our app-to-app communication story for Windows Store apps. And that's what I'm here to talk to you about today, building apps that work together. I'm going to take a few minutes here in the beginning of the talk and give you guys an overview of how apps can work together today on Windows. And then for the majority of the talk, I'm going to talk about how we've improved that experience for Windows 8.1. Now, the first question that you guys might be asking yourselves is, why should I care about this particular area? Why can't I just kind of create all the functionality I need in my own apps? And that's kind of a natural inclination that we have as developers. We want to control our own scenarios. But the truth of it is that as a developer, you only have so much time and so many resources to actually go and build great apps. You want to spend that time, making the core features of your apps really great. The trouble is, your users are always going to expect more functionality than you actually have time to build. They're always going to want some more features there. And this is where working together with other apps comes in really handy. You can go and you can utilize the core features of all those other apps in the ecosystem and use them to complete your own end-to-end scenarios. And I've got a demo over here to kind of show you what I'm talking about here. Let me switch over to my demo machine. And up here I've got the Fotor photo editing app. Now, one thing about me is I'm a pretty big hiker. I like getting out into the mountains, the beaches, you name it. I'm actually going to be spending the weekend here in California after build doing some hiking around here. So if anybody has good suggestions for hikes, love to hear them afterwards. But anyways, back to the app. When I go and I do these hikes, I come back and I've got lots of photos. And I often want to edit some of these. So I can come into Fotor here and select a photo from one of my hikes I've done. This one's from a hike up Mount St. Helens. I'll come into the app. I can do a little auto enhancement here, maybe add an effect. How about a black and white effect here? There we go. That looks pretty cool. And you can see the Fotor app gives a really great photo editing experience. They spent a lot of time making this experience great. It's touch-friendly. There's a lot of functionality here. The app looks really nice. But as an end user, another thing that I want to do with my photos, once I've gone and spent this time editing them, is I want to be able to share them with my friends. Now, the Fotor app developer, they could go and they could implement this functionality themselves, right? They could go and they could figure out the set of services that they want to share their photos to. They can figure out how they can authenticate their users with each service, how to use the different APIs to upload the data, and then maintain all those different connections over time. But that actually adds up to quite a bit of work. And it's work that takes away from making this core editing experience really great. So instead, the Fotor app goes and they work together with other apps using the share contract. So all I need to do to share a photo here is come into the charms, select share, pick an app to share to like Twitter. Can come in here and select some text, type a little bit, I hit tweet, and I'm done and I'm back in my app. Fotor is able to do this with just a few lines of share code. It's really easy for them. And so what you saw there in the demo is by working together with other apps, you can go and you can complete your end-to-end experiences, and you can do so more efficiently and spend less development time and resources on those features. In Windows 8, we recognized this, and we created a mechanism for apps to communicate, which we called contracts. The basic premise of a contract is that it's made up of both a source app and a target app. Now, the source app is the app that initiates the communication. In our example there, it was the Photo app, which is sharing the data, while the Target app is the app that receives the communication. It takes in the data and then performs some action on it. And in Windows 8, we created several of these different contracts. The first set of those were the file and the URI contracts. And these allow apps to communicate by passing data in the forms of different file types or URI schemes. The next was the share contract. And this is what I just showed you in the demo, so you got a good feeling for that. And then finally, the picker contracts. And there are two of these, the file picker and the people picker. Now, for the rest of the talk today, I'm not going to go into a lot more detail about the existing features of each of these contracts. We have a lot of great documentation out there already, and I linked to a bunch of these in the resources slide at the end of the deck. So if you're interested in learning more, you'll definitely want to go check that out after the talk today. All right, now for the more interesting stuff. What's new in Windows 8.1? The first thing I'm going to talk about is how you can use the file and the URI contracts to create engaging and seamless multitasking experiences between your apps. The next is using the improvements we've made to the share contract to create rich and compelling share experiences that end up bringing users back to your apps through share. And then finally, I want to give you guys an introduction to two brand new contracts that we've created that allow you to easily integrate with the user's contacts and calendar events. All right, let's get started with multitasking with files and URIs. Now, multitasking with files and URIs isn't a new concept. This is something that we all do every day. Sure, we've all gone into our email apps, invoked a link, brought up the web browser, and started browsing the web and viewing and replying to emails at the same time. The trouble is that there's always been this need for user configuration in this scenario, right? As a user, you always have to go and manually resize and reconfigure your windows, and then you can start multitasking. To kind of show you what I'm talking about, I'm going to switch over back to my demo machine. And I'm going to bring up the Mail app, which I have running in a Windows 8 VM here. Now, in the Mail app, I've got an email from my friend Allison, and she's asking me some questions about buying a new Surface. Now I want to go ahead and I want to start a reply to Allison. And when I do that, I want to check out some of these links she sent me, so I know, I know what she's asking. Now, when I go and do that, you'll see the web browser launches, but it comes up over top of my reply. I can't start multitasking yet. To do that, I have to come over, grab the Mail app from my backstack, kind of drag it on screen here, reposition it, drop it in. Now I can actually start multitasking. I can start my reply. And that scenario, it's functional, right? It works. But there's some extra friction there. There's extra steps for the user for something that should really just be seamless and easy. In Windows 8.1, we wanted to allow your apps to get rid of this friction. We wanted to let you make this a seamless scenario for your users. And to show you that, I'm going to jump over to the Mail app again, but this time I'm running on Windows 8.1. I've got the same mail from Allison. I can come in here and start the reply. And when I invoke one of these links, you'll see the browser launches, but it comes up side by side with the Mail app. This is something you guys might have seen in the keynotes yesterday and other talks. And this is a pretty neat experience because it allows me just to start multitasking right away. I can come in, click on more links, start replying. It's a really seamless scenario. And this is something that we know your users are going to love. I've got a clip here from some user studies that we've done where we showed real end users this functionality working in their apps for the very first time. And I think their reactions kind of speak for themselves.
All right. I'll click on the link. Oh, nice. It's side by side. from the email and the app. I like that right there.
Ah, that's nice.
Or tap on it.
Okay. Oh, and it did it right there. I didn't have to do anything special.
Oh, now that was nice.
So I think the easiest thing to do here, oh good, it opens right in the same screen. I really like that, the fact that it opens side by side automatically when you click the link, rather than opening to replace the app.
I really love that last end user's reaction. She basically sums up everything I'm trying to say in the last 5 minutes in that one sentence there. Now, I'm sure that the next thing you're wondering as developers is, how do you go and create this experience in your app? How do you get those reactions from your end users? Up here on the slide, I have the code that you would need to write to launch a URI on Windows 8. You go create the URI and launch it. It's pretty straightforward, right? You can imagine when you'd have to take into account positioning another app on the screen, the experience could get quite a bit more complex. For example, you'd have to take into account how many apps are already on screen and what's the screen resolution. If there's 2 apps on screen and there's enough screen resolution there, maybe you can fit a third app. But if the screen resolution is too small, you might have to replace a different app. Or say the device is in portrait mode. In that case, we only support 1 app on screen at a time. And so what do you do in all these different cases? The great thing is for developers in Windows 8.1, you don't have to worry about any of those different factors. These are things that Windows takes care of you by default to create a great multitasking experience for your users. So the code that you need to write in Windows 8.1 to launch this URI and let your users multitask, it's exactly the same. You get the experience by default. The only thing you're going to want to think about then as a developer using these contracts in your app is how your app looks and behaves at the new fluid window sizes that Windows 8.1 supports. And this isn't something that's unique to the file and URI contracts. This is something all your apps will have to take into account in Windows 8.1, because users can always kind of manually reconfigure and resize your apps to any size. But you definitely want to think about it when using these contracts to make sure you give a great multitasking experience at all these window sizes. And my colleague, Sarah McDevitt, actually has a talk going on right now titled Beautiful Apps at Any Size on Any Screen. And I'd highly encourage you to go check that out online once it's posted, since she gives a lot of great design guidance and tips on creating great apps at different window sizes. So as you can see, by default, when you use the file and URI contracts on Windows 8.1, you're going to get this great multitasking experience for your users. And for most apps, that's probably as far as you're going to need to go. In most cases, the default is exactly what the user needs. But when we were developing the feature, we realized that there are going to be some cases where your apps may want to influence that default behavior. One of those cases is when, as a source app, you actually prefer to be a different size when you're launched. You saw the default as that 50-50 kind of side-by-side state, but maybe a different size works best. For example, if your app is launching the video app through a URI or through a video file, you might want to stay on screen to let users multitask with your app, but you want to let the video app take up more of the screen space. You want the user to be more immersed in their media content. Another case could be when, as a target app, you prefer a different size. So in these cases, you might be an instant messaging app where when you're launched through a URI, you want to take up the minimum amount of screen space available. That way, the user can message in your app, but they still get most of their space there in the source app. And finally, there are going to be some cases where multitasking simply isn't required. For example, if your app goes and you launch, say, a game through a URI, the user probably doesn't need to multitask between your app and the game. In those cases, you'll want your app to go into the background and give the game the full amount of screen space available. To do all of this, we've created a set of preferences that you can specify when using the file and URI contracts in your app. And I want to kind of show you a demo of these preferences in action and how you can actually add these to your apps. Switch back to the demo machine here. And I'm going to go ahead and launch a demo app that I created for the talk today. You see I'm continuing with the theme of hiking here. I've got a little app, uses the new hub control, shows off some pictures and some descriptions of different hikes I've done. And when I come in here, you can see there's a button there that finds the start of the trail on the map. And what happens here is when I invoke that button, I go and launch the Bing Maps app using a URI. And you see, the Maps app comes up, and it automatically launches in this side-by-side state, so I can start multitasking. And this is that default 50-50 view that you saw earlier. Now, let's say we want to go and we want to actually influence this behavior. We want to set a preference. To do that, I'll jump over to Visual Studio, where you can see the code I have running for the app. And in here is the handler for that button that actually goes and launches the URI. Now, this code is very similar to what you saw on the slide earlier. It's the same code I would have written in Windows 8. And I'm going to go ahead and add a few more lines of code that actually go and set a preference. What I'm doing here is I create this launcher options object. And on that, I set the desired remaining view property. And this is a new property that we've built for Windows 8.1. And it represents your app's desired window size after you go and launch the URI. You can set this by coming in and using this view size preference enum here. And this enum actually has several different options, which you can see in Visual Studio. And when I set the option of, say, use none, what I'm telling Windows is that my app, as the source app, doesn't need to use any of the available screen space after I launch the URI. I'm going to go ahead and run the app again. And this time, you'll see a different experience when I go tap on the button. You can see here the Maps app comes up, and it launches full screen. And this is because Windows is taking that preference of use none that I set, and it's applying it to the URI launch. And like I showed you, there are several different preferences here. So if we say we want users to multitask, but let's say we want our app to use less of the screen space, I can go set my preference of use less, go ahead and launch the app. And this time, you can see the Maps app launches here, and my app stays on screen, but it takes up a smaller amount of space. Now, this is probably a good point to re-emphasize that these preferences that I'm setting here, they're just that, they're preferences. Windows is always going to take into account several different factors when doing a file or URI launch. It goes and it looks at the preference that the source app sets. It looks at the target app's preference. And it also takes into account things like the number of apps on screen, the screen resolution, and the orientation of the device. And it combines everything together to kind of try to create the best possible experience for your users. So as a developer, when you're using these contracts and you're setting the preferences, you always want to be prepared to be launched and sized at any size, regardless of the preference you set. Now, with that disclaimer out of the way, I also mentioned that target apps can set a preference. And to do that, you can set it in your manifest here. Now, I've gone and I've registered this demo app for its own little custom URI scheme. And if I switch over to the Mail app again, I've emailed myself a link to the app. And when I launch that, you see my app comes up, and it comes into this 50-50 default view that you've been seeing a lot now. And this is because neither of these apps is actually specifying a preference here. As a target app, I haven't gone and set a preference. To do that, though, it's really easy. All I have to do is come into the Manifest Designer, and I'll zoom in there so you can see it. There's a new desired view dropdown, and it has a similar set of preferences to what you saw when we set the source app preference. And I can come in here and set a preference of, say, use more. And what I'm saying here is that as the target app, my app wants to use more of the available screen space after I go and I'm launched for this URI scheme. And you can set one of these preferences for each URI scheme and each file type that your app supports. So let me go ahead and launch this one last time. Jump back to the Mail app, and I'll invoke this link again. And now you can see the behavior has changed, and our app comes up, and it takes up more of the available screen space. Up here, I kind of have a slide that just summarizes some of the things we just talked about there in the demo. So I won't go back through all that, but it's there for your reference if you want to come back to it later. And so what I kind of want you to take away from this here is that by default, whenever you use the file in the URI contracts, Windows is going to provide a great multitasking experience for your end users. But as a developer, you always have the option to set a preference and influence that behavior. Yes? Sorry? So actually, if you can come up after the presentation, I can actually give you a lot more details than that. There's a lot of complexities there. So definitely find me after the presentation. I'll talk more. All right. So now I'm going to switch gears a little bit, and we're going to start talking about the share contract. I'm going to start off, and I'm going to talk about how we've gone and improved the share source side of the contract, and then move into some of the improvements we've made for share target apps. Now, the first thing you're going to want to consider when you're building a share source app is how does the content you're sharing add value for the end user? And this is an important point to think about, because even if you spend lots of time and effort, building a great share experience, if your content's not valuable to the user, they're still not going to go and share from your app. And for some apps, you just may not have great content to share. And that's actually OK. In Windows 8.1, we've gone and we've created new default share options. So the user can always share both a screenshot and a link to your app's page in the store. So your app's always sharing something by default. Now let's say you do have some interesting content to share. The next thing that you're going to want to think about is how do you represent that content in as many different data formats as are applicable. And this is important because the more data formats you can support as a source app, the more flexibility you give your users when they're sharing from your app. Now, one of the data formats that I wanted to spend a little bit more time on today was the URI data format. In Windows 8, we saw that there were a lot of apps that could represent their content using a URI. And many of these apps would actually have representations of this content both up on the website and locally within their app. The trouble was that in Windows 8, the share contract only supported a single URI data format. So as an app developer, you kind of had to choose whether or not you were going to share the web content and make sure you're compatible with all the different share target apps out there, or you're going to share the richer, the more immersive local content, but risk being incompatible with share targets that only supported the HTTP URI scheme. In Windows 8.1, we've gone and we've helped you out here by replacing the URI data format with two new formats, the web link and the application link. The names here are pretty self-explanatory. The web link is a URI that points off to data that's content that's on the web, and the application link is a URI that points to local content within your app. Now, as a source app developer, if you have content both on the web and locally, you always want to share both these new data formats, again, to give your users more flexibility when they're sharing from your app. Once you've gone and you've figured out all the different data formats that your app's going to support and share, the next thing you want to think about is how you can represent that data in target apps. Basically, you want to make sure your data looks great. You can do this using the properties on the data package where you set your data formats. And in Windows 8, we had a set of properties that you could set here: the title, the description, and the thumbnail. And in Windows 8.1, you should continue to use these properties to provide this metadata to target apps. But we've also created some new properties that help you give even more information there. The first two that we've created are the square 30 by 30 logo and the logo background color. And these are actually set for you by default whenever you go and share something from your app. Windows sets these to your tile logo and your tile's background color. And basically what these properties are for is they allow target apps to attribute that the content that they're showing in their app is coming from your source app. Now, as a developer, if the content is actually coming from a specific part of your app that you want to attribute, or from somewhere outside of your app, you can always go and override these with a different logo and a different background color if you want. The other new properties that we created were the content source web link and the content source application link. Now, these are very similar to those application link and web link data formats that I talked about earlier, but these you use to attribute where other data formats are actually coming from. So for example, if your app is sharing a photo from, say, a news article within your app, you can go and you can set the content source application link to a URI that points back to that article. That way, when apps go and share that photo off, they can share the URI with it, so users looking at the photo can come back into your app to that article. It's another great way to kind of bring users into your app through share. OK, I did a lot of talking there. Now I want to kind of go and show you guys some of this in action and show you how you can use some of these new data formats and properties in your apps. I'm going to go ahead and switch back to the demo machine here. And let me bring up Internet Explorer first. And I want to kind of show you a really good example of how a source app can pass data over to the target. See up here, I've got the MSN Autos page, and I'm actually on here a lot. I'm a pretty big car guy, love reading about new cars, love driving them. Actually, probably one of the only people from Microsoft that actually drove down here from Seattle, just to get a taste of some of those mountain roads you guys have here in California. Really jealous of those, by the way. But anyways, when I'm on here, I often find that I've got more articles to read than I actually have time for. For example, I'd love to read about the new Cayman, but I've got to keep talking to you guys for another 20 minutes. So instead, I'm going to go ahead and share this to the Reading List app. Now, up here, what you'll see is Internet Explorer isn't just passing the URI to the website. Right? They're passing a lot of extra metadata that allows Reading Lists to give a great representation here in the target view. You can see they pass in a title for the page has a description, they have a great image that really represents the content, and they even use those new display properties that I talked about to attribute the fact that this content is coming from the MSN page within the browser. Now I'm going to go ahead and share that, and now I want to go over to Visual Studio and show you how you can create that type of share experience in your apps. Over here, I've got just some share boilerplate code here, which registers for the data requested event. And this is the event that indicates that the user wants to share something from your app. Now, you can see here in the handler, I haven't actually written any code yet for share. And let me just show you then the experience that I'm going to get from this app. I can come over here to the share charm, and when I launch that, you'll see I don't have anything to share explicitly, and that makes sense. I haven't written any code yet. But you'll notice, if you can see there in the drop-down, I can still share a screenshot of the app. And if this was an actual app in the store, and not just a demo app, you'd see an option to share a link to this app's page in the store as well. So that's the default experience. Let's go over to Visual Studio again, and let's add some code in here to actually support share. There we go. This is kind of the minimum amount of code you need to write to support the share contract. All I'm doing is I grab the data package from the event args. Then I go and I create a URI, which points to that specific page we were viewing in the demo app. And I use the new setApplicationLink method to add this URI to the data package. Then finally, I set a title for the content. And now I've actually supported share. And this is OK. But what you'll notice is that I'm not giving a lot of that extra metadata and extra data formats that's going to allow share targets to give a great representation of this content in their app. And I want to do that since that's an important piece of getting users excited about sharing from my app. So I'm going to go and I'm going to add a few more lines of code to help do that. Now, what I've gone and done here is I've continued on, and I also set this description property that you saw. Now, you'll notice that for both the title and the description, I'm just using content that I'm already setting in my app in other places. So it's really not a lot of effort to just go and add these to the data package as well. I also go and I grab the main image that we were seeing on the page, and I use that to set both the bitmap data format here and the thumbnail property. This way, I'm giving a lot more flexibility to target apps on how they can give a visual representation of this content. Finally, I go and I set the new content source application link property. And I set this to the same URI that I'm setting the application link to. This way, for apps that only handle sharing that bitmap data format, they can still grab the URI from this property and pass that along with the photo so that users can still get back to the original source of the content. Yeah? So the question was how you differentiate between application link data format and the content source application link, right? So for a target app, they actually will register to handle the application link data format, but they don't register for this property. This can be set on any data format. So that's kind of the difference there. And that's why it's good to provide both if you're setting multiple data formats here. Now I'm going to go and run this here. And when we come over here to the share pane, you'll see right away I've now got some options to share to. And this is because I'm supporting those different data formats. And when I choose the reading list app, something goes wrong. Let me try one more time. There we go. What you'll see is that reading list is able to give a great representation of that content that we shared. We have the title, we have the description, we have this great image that represents what this page is. And as a user, this is a really compelling share experience for me. So I'll go ahead and I'll share that to reading list. I can jump back to the main version of the reading list app, and you'll see there's the content that we just shared. And even if I come back to reading list, say, days later, it's still going to be really obvious to me, what this content is, and it's going to remind me that, yeah, I wanted to view this later. When I tap on it, it uses that application link URI to go and launch my app again. And as a user, I come back into that app. And that's really kind of the beauty of the new improvements we've done for share in Windows 8.1. If you go and you take the time to create a really rich and a compelling share experience in your apps, you can use the new things like application link and content source application link and the display properties to get users interested to come back into your app after they've shared your content. Now, the other piece of this story, the other side of it that I was showing there, is the share target apps. And we've made a few improvements here as well. One of the first things we noticed when end users were sharing in Windows 8 is that they frequently wouldn't know what the target apps were going to do with the data that's being passed to them. Right? And so what they would actually have to do is they'd go into the share pane, they'd see this long list of apps here, and you'd have to go in and open up lots of different individual apps to see what each one's actually going to do with your content. And the trouble with this is it added extra friction and added extra time to what should be a really quick and easy scenario. So in Windows 8.1, we allow you to make this easier for your users and get them to your apps quicker by providing a description of what your app is going to do with the shared content. And you can provide this description by setting it in your manifest. Now, when you go ahead and you set that, you're going to see an experience like this, where underneath the reading list app there, that text you set in the manifest shows up on screen. So as a user, it's really easy for me to see, hey, reading list is the app that's going to bookmark this content for later, and that's what I want to do, and so I can jump right into the app there. I don't need to open up multiple things. The other thing that we noticed was that share target apps oftentimes took a few seconds to complete the share operation. And during this time, the app would stay there up on screen, and the user is kind of put into this limbo state, right? There's nothing left for them to do in the share target, but they can't yet get back to what they were doing in the source app. So to make this easier for your users, in Windows 8.1, you can use the new dismiss UI method off of the share operation object. And you can do this to programmatically close the share pane as soon as you've gotten all the input you need from your users. This way, the user gets right back into what they were doing with the source app, and your app can finish the share operation safely in the background. Now, the final thing I wanted to talk about for share targets was how you can use those new application link and web link data formats that I talked about earlier. I've already kind of gone over the different scenarios here, but I wanted to talk about kind of which one of these you actually register for as a target app. And what you'll want to think about here is what type of sharing your target app actually does. And there are really two types of this in the ecosystem today. One type of app goes and shares the content locally on the device or within the Windows ecosystem. The reading list app that I showed is a great example of this. We'll call that client sharing. The other type of share target will often share the data off of the device, either to a cloud service or another user, and we'll call this cloud sharing. Now, as a cloud sharing target app, you'll probably want to go and register to handle the web link data format. This way, no matter where that content ends up going, you can always be confident that users are going to be able to get back to it using the web browser on their device. However, if you go and you're primarily doing client sharing, you keep the data locally within the Windows ecosystem, then you already know that the user is running on Windows, and they have the app that gave you the content. So in this case, you'll want to register for the application link to provide the most immersive and the most complete form of the content for your users. Now, when you look at all the different improvements we've done for share target apps, what you'll find is really we've just given you more flexibility and more power as a developer to create rich and compelling share experiences that get users more excited to share to your apps. And that's a great thing, because the more excited users are to share to your apps, the more users you'll bring into your apps as a share target. OK, so for the last few minutes here, I want to go and give you a little introduction to two of the new contracts we've created in Windows 8.1. And these contracts allow you to easily integrate with the user's contacts and calendar events. The first of these is the contact card. Now, as we were developing Windows 8.1, what we wanted to do is give app developers like yourselves an easy way to integrate with the user's contacts. We wanted to give you a way to display contact data and let users connect with their contacts. But at the same time, we wanted to make sure the users were confident that their contact data was staying safe and secure within Windows. And the contact card was our solution to this. Now, rather than kind of talk about this for a while, I think it'd be easiest just to show you it in a real demo. And to do that, I'm going to jump back over to the Mail app. Now, if I come into this email that Allison sent me, and let's say that I want to view some contact information for Allison. If I want to do that, I can tap on her name in Mail here, and you'll see the contact card come up. Now, what's happening behind the scenes here is the Mail app is actually passing Allison's email address over to the contact card contract, over to Windows. And Windows is taking the email address and it's using it to query against all my contacts in my local contacts database. And these are the contacts that I get when I go and hook up different services to my Microsoft account. And since I have Allison as a contact, Windows grabs her information and it displays it on the contact card. Now, none of the data is actually passed to the Mail app here, but because the contact card is contextual and lightweight, as a user, it still feels like I'm interacting with Mail. It doesn't feel like I've completely left the context of my app. You'll also notice that the contact card shows a set of communication actions there. And I can go and tap on one of these, like Map Address, and that'll go ahead and launch the Maps app to Allison's location. And from here, I can go and get directions or see more information on the location. But because it comes up side by side, it's still really easy for me to go and interact with the Mail app as well. I never kind of leave that context. So that's kind of pretty cool functionality there. And those communication actions that you saw are one of the important reasons that the contact card is a key way that apps can work together on Windows 8.1. If your app needs to go and let your users connect with their contacts, you don't have to worry about creating each communication action all there within your own app, because you can utilize the contact card and through it other apps to go and create those communication experiences for you. And up here on the slide, you'll see the full set of different communication actions that can be shown on the card. And each of these is kind of chosen to show depending on the data that's available for the contact that you're displaying. So as a developer, if you need to let users either view contact information or connect with their contacts in your apps, definitely look into the contact card contract as a way to do this. The other new contract that we've created for Windows 8.1 is the calendar contract. And this is actually very similar to the contact card in that we wanted to give your apps an easy way to integrate with the user's calendar events. But at the same time, we wanted users to feel like they were staying in control of their calendar experiences. And this is why we created the calendar contract. And again, I'm going to go ahead and I'm just going to show this to you in another demo. I'm going to bring up this little demo events app that I have, and it just shows some conferences and some events that I've been invited to. I'm going to jump into the build event. And what you'll see is that I've got an option to go and view my calendar. When I tap on that, what's happening under the covers is the Events app uses the calendar contract to pass time frame information about this event, and then it requests that the calendar app show any other events that are happening during this time. And I see I can look at my calendar here, and I see there's not much going on, which is probably good because I'm here talking to you right now at the conference. And when I do that, I can go and add the event to my calendar. Now, what the Events app does here is they go and they pass all the event information off to the calendar contract, and then they request that the calendar app add the event to the user's calendar. Now, once that's done, the calendar app itself is actually launched in this lightweight hosted flyout that you see here. Now, obviously, this isn't the real calendar app. This is just a demo that we've created here. The real one will be much prettier. But you can still see that it's very easy for me to quickly view my event information and go ahead and confirm that, yep, I want to add this to my calendar. And just like the contact card, the calendar contract is another way that your apps can work together on Windows 8.1. And view and add aren't the only things that your app can do with the contract. You can also go and modify and remove different events that your app has set. So again, if you're looking to integrate with the user's calendar events, the calendar contract is a great way to do so in Windows 8.1. Now, there's a ton more details here about both the calendar contract and the contact card, which I just don't have time to go into here in this talk right now. But coming up, my colleague Zanab Hakim is giving a talk titled Building Apps That Integrate with People and Events. And in that one, she actually goes and she dives into lots more details of both the user experience and the developer experience of how you go and add these contracts to your apps. And that one's actually coming up right here in this room, I believe, just after lunch. So just come back in here. You don't have to worry about getting lost in all the different hallways that we have set up. All right. So with all those different improvements that you saw, what you really can take away here is that it's even easier than before to work together with other apps on Windows 8.1. You can use the file and the URI contracts to create seamless and engaging multitasking experiences for your users. And you can use the new preferences that we've added to influence those experiences to fit your scenarios. You can use the improvements we've made to the share contract as both a share target and a share source developer to create rich and compelling share experiences that bring the users back to your app. And then finally, you can use the new contact card and calendar contracts to easily integrate with the user's contacts and calendars, and at the same time, keep users confident that their data is staying safe and secure. Up here, I've got the resources slide that I promised. You can see there are the other two talks that I referenced and some links to documentation for the different contracts that I talked about today. And with that, I'd like to thank you all for coming. I'm actually going to be available off stage for a few minutes to answer some questions that you might have. And I'll also be at the Windows booths in the expo hall this afternoon from around 3 to 5. So if you think of more questions, definitely stop by. Thanks, everyone.